Okay, this is the notes for section 5.4, solving systems using linear combinations. So this is our basically our third method of solving solving systems. We looked at using your CAS both graphically, all three ways graphically, using tables, and also using the solve function. Then we looked at substitution in section 5.3. Now we're going to look at a new method called linear combinations. In the linear combination method, what we're doing is we're basically using multiples of the linear equations to eliminate a variable to solve for one of the variables, and then we use that to find the other one. Okay, so what we want to do, and by the way, this method works best when we have our equations set up in standard form. So one of the keys to this one is that we're always working with things in standard form when we're using this method. Okay, so if it's not in standard form and you want to use this method, you want to put it in standard form. Okay, so let's take a look at example 1 here. It says solve the system 5x minus 6y equals 3 and 2x plus 12y equals 12 using linear combinations. So what I'm going to do is I want to take multiples of these equations such that one of the variables, when I add the two equations together, would be eliminated. So as I look at this, I have a negative 6y here and a positive 12y here. So if I multiply this top equation through by 2, okay, both sides through by 2, by doing that, I would end up here with a negative 12y, and when I add it to this positive 12y, my y's are going to eliminate. So one of the keys to the linear combination method is that we're always looking for a way to eliminate one of the variables. Okay? So I've taken the top equation, I've multiplied through by 2, and the new top equation then would be 10x minus 12y equals 6. Remember, now that's an equivalent equation because all I did was multiply both sides by the same thing. So now what I'm going to do is if I add these two equations together, my positive 12y and negative 12y, those are going to cancel out. So I'm left with, on the left side, 12x, and on the right side, 18. Okay? So I get 12x equals 18, and then I can divide both sides by 12, which is what I'm doing here. 18 divided by 12 then is equal to 3/2. Therefore, my value of x is going to be 3/2. Now, the next thing I want to do is I want to solve for y. So I can take this and I can plug my x value in for y into any of my equations. Okay, and it doesn't matter which one. I actually elected to use this 10x minus 12y equals 6, and that's okay. I could use one of the original ones or one of the multiple ones. If I do that, I find that y is equal to 3/4. Therefore, the solution to this system is the ordered pair 3/2, 3/4. Okay, let's take a look at example 2 then. It says 5 yards of fabric and 3 spools of thread cost $40.12. 2 yards of the same fabric and 10 spools of the same thread cost $23.88. Find the cost of a yard of fabric and the cost of a spool of thread. Let F equal the yards of fabric and S equal the spools of thread. Okay, so the first thing that we want to do is we want to take that information and write a system of equations for it. So if what I'm going to do is I'm going to say, well, let's let F equal the yards of fabric, and we'll let S equal the number of spools of thread. Okay, if that's the case, then I can take this first sentence, 5 yards of fabric and 3 spools of thread, and write 5F plus 2S is equal to 40/12. Okay, and then I can do the same thing with the second sentence where it says 2 yards of the same fabric and 10 spools, so I can go 2F plus 10s is equal to the cost of $23.88. So by doing that, I've come up with a system of two equations. When we have word problems like this in this chapter, when we're dealing with systems, our goal is to write a system of equations, and that's what we've done now. Okay? So if I'm going to solve this, I'm going to use linear combinations to do that. Okay? So as I look at what I have here, I can eliminate either one of those variables. What I've chosen to do is I've chosen to eliminate the f's. So what I did is I took the top equation and I multiplied it by 2 all the way through. And then I took the bottom equation and I multiplied it through by -5. By doing that, this becomes the top one becomes a 10f, the bottom one becomes a -10f, in which case I can go ahead and cancel those out to come up with where I'm at in terms of trying to solve for one of the variables. Okay, that's exactly what I've done here. I've canceled out the f's, so I'm left with -44s is equal to -3916. Okay, and then if I divide both sides by -44, I'm going to get my final answer, which is s is equal to 89 cents. Okay, so once I have that value, that's one thing that I need to know. The other thing that I need to know is I need to know how much the fabric costs. So now that I know s, I can plug it into any one of my equations. Any one of these four equations will work. I've just decided to plug it into the very first one here. If I do that, I put 89 cents in here for s. Okay, multiply it through. 5f is equal to 267, or excuse me, 5f plus 267 is equal to 4012. Subtract $2.67 from both sides and then divide by 5. So f would be equal to 37.45 over 5, which comes out to be $7.49. Therefore, that would be the cost of the fabric per yard, $7.49. And we've now solved for what we were asked to solve for.